So in the last class, we have gone through the object-oriented programming, right? Just a minute, please. Right? So we have gone through object-oriented programming. Yes. So we saw how to create, how to implement that object-oriented concepts. You know the difference between a Java class and a Java method. Okay, you know the difference between a Java class and a Java method. So now we'll talk about the implementation of behaviors, how to implement behaviors. Okay. Yeah. So we saw constructor also in the last class, right? So what is a constructor? Why do we use a constructor? Yes, can you people tell me? What is a constructor? So why do we use a constructor? Yes. Could you please explain what is a constructor? To initialize an object. To initialize an object. So we use a constructor to initialize an object. Right? Yeah. Yes. So initializing an object means, yes, that's also right. Constructor has got same name as a class name. It's a special method, you can say. Again, say initialization. When we talk about initialization, so what does it mean actually? So initialization is all about assigning some initial values to the instance variables which are part of the object. I gave you people some notes in the last class, right? Initialization means assigning some initial values to the instance variables, yes, which are part of the object. That is initialization. Okay, good. So today we'll move ahead. We'll carry forward our discussion. In the last class, we saw that you see this fields. So we use them, or this fields basically, they represent the properties of an object, right? This fields, or we say instance variables or non-static variables. You got several names, all means the same. So they represent the properties of an object, right? Yes. And what is special about this objects? What did I say? Yes. Sorry, what is special about this variables? You see, whenever we create an object, immediately the memory for that object will be allocated for that instance variables. Immediately the memory for the object will be allocated, right? Yeah. So every object will have a copy of this. Every object will have its own copy of this instance variables. Every object has got a copy of instance variables here. Yes. So if you create 100 objects, you'll have 100 copies of instance variables. You have 100 copies of instance variables. Every object has got its own copy of instance variables. Yes. Next, you see, uh, actually, even we have discussed about this, the reason why we need a separate copy of this instance variables for every object, because you see, you'll find that the instance variables, they represent the properties of an object. This properties, the property values here, they will change from object to object, right? Every object has got its own set of values, so which is different from others. So this property values will change from object to object. The property values will change from object to object. No two account numbers will be same, balance will be same. That's the reason why you see you need a separate copy of this. You need a separate copy of variables in each object. For this instance variables. Instance variables, they represent the properties as I told you. Yes. But you know what? Here you will find that you may have objects, sorry, you may have properties in an object whose values will not change from object to object. Okay. You may have properties in an object whose values may not change from object to object. Can you identify any property in the object whose value will not change from object to object? Yes. Not string. I'm talking about properties of an object. You see, for example, here in this example, we are considering savings account object, right? We are talking about savings account object. Can you identify any one of the property of a savings account object whose value will not change from savings account to savings account? Minimum balance. Yes, that's right. So minimum balance of savings account is a property whose value will not change from object to object. That means account to account, savings account to savings account, that minimum balance will not change. And one more thing, interest rate. You know, for the savings account, the banks will pay interest. You know that. Hope you are aware of it. For the savings account, the banks will pay interest. Yes. So this interest will be same for all the savings accounts. This interest will be same for all the savings accounts. Okay. So even this property value is not changing from object to object. It's just a minute, please. Just a minute. Yeah, I'm sorry. So you see, for suppose if I represent this property of an object here in the class as an instance variable. So let me do this, okay? Float, let's say interest rate 3.25. Let's say this is the interest rate. You know what? This property value, as I'm telling you people once again, it won't change from object to object. For all the savings accounts, the interest rate offered by the bank will be same. Okay? Yes. Okay. So here, if I declare this variable as an instance variable, okay, yes, then what happens? Let's see, we'll try to analyze this. For suppose if I create 100 objects, then how many copies of interest rate variable will be there in this case? How many copies of interest rate variables will be there? 100 will be there. You'll have 100 copies. So in all the 100 copies, you have the same value. Am I right? In all the 100 copies, you have the same value, 3.25. Will it change from object to object? I said no, right? It is going to be same. Okay, for suppose if you have 1000 objects, for suppose if you have 1000 objects, then 1000 copies of interest rate variables will be created. In all the 1000 copies, you'll have the same value. In all the 1000 copies, you'll have the same value. So, do you think is it really necessary? Do we need 1000 copies to store the same value? If we create 1000 objects, 1000 copies of interest rate variable will be available, right? No, 1000 copies are not needed to store the same value. It's simply waste of memory. It is simply waste of memory. Yes. So what to do then here? In this case, what to do? Not methods. What you can do is here, you can declare this variable as static. Yes, declare this variable as static. What happens if we declare this variable as static? You see, you will find that there will be only one copy of this static variable. There will be only one copy of this static variable. Okay, no matter how many objects you create, it doesn't matter how many objects you create, you'll have just one copy of static variables. You'll just have one copy of static variables. That's it. There will be only one copy of the static variable. Even if you create 1000 objects, still there will be just one copy. Even if you create 1000 objects, there will be one copy. That's it. Okay? Yeah. So all the objects which belong to the savings account object, which belong to the savings account class, I'm sorry, all the objects which belong to this savings account class, they'll share the same copy of static variable. They all will share the same copy of static variable. Okay? Yes. So this way, the variables in a class, you can classify them into two types: static variables and non-static variables, or instance variables. When we talk about instance variables, every object will have its own copy of this instance variables, whereas static variable, there will be only one copy of the static variable for the complete class, no matter how many objects are created. So basically, now both the variables, they represent the properties of an object, but instance variables, they represent the properties of an object whose values will change from object to object, I can say. Instance variables, they represent the properties of an object whose values will change from object to object. Yes. Instance variables, they represent the properties of an object whose values will change from object to object. Yes. Whereas static variables, they represent the properties of an object whose values will not change from object to object, I can say. Okay. Static variables, they represent the properties of an object whose values will not change from object to object. They represent the properties of an object whose values will not change from object to object, I can say. They're going to be same. Yes. That's it. So, any questions in this regard, please let me know. Now you know how to represent
Hi,
instance variables and static variables. Yes. Yeah, any questions?
hi, good morning.
Yeah, tell me.
Uh, there are two constructors in the savings class account, public savings account default and the initialize constructor. Do you need it?
Uh, Actually, I'm sorry. Your voice was not clear. Could you please come again?
Um, there are two constructors in the same class.
Okay.
Do
Yeah.
you need it?
Yeah. So you're talking about constructors. So we have two constructors in the class. That's right. So your question is, um, do we need both the constructors? That is what your question is, right?
Yes.
Okay. Um, you see, generally what happens is, as I told in I guess day before yesterday's class, it's not day before yesterday, just yesterday's class itself, I guess. Yeah, yesterday itself. So when I was talking about a constructor, as I told you people, so if you don't add any constructor to the class, a default constructor will be added. A default constructor will be added. You know, a default constructor, as of now, I'm not using it. We are only using a parameterized constructor in this case, right? We're using a parameterized constructor. Now, what is the purpose of default constructor here? As of now, there is no use. But for suppose, let's say, just take an instance where we don't have any values for that object. Let's say we don't have any values. Then you can use the default constructor to assign some default values, something like this. This dot account number 0, this dot balance. Though you'll have default values, okay, still you can do this 0 status. Let's say, you know, this dot status is a new. So pin number. So just to assign some default set of values, you can make use of default constructor. If you don't have, for say, let's say if you don't have any values to initialize, in that case, maybe you can make use of this default constructor. Otherwise, as of now, there is no use for it. So if you don't have any values to initialize an object, then You see, you can call a default constructor, which will set the default values. It will set the default values. Yes. So you got it?
Um, yeah, I got it. And I have one more question.
Yeah, tell me.
We call constructor to initialize an object, right?
Yeah,
So actually, we are initializing instance variables.
yes.
So why don't we call constructors to initialize instance variables?
We are calling it as part of the object creation statement. We are calling that constructor as part of the object
Um,
creation statement. When you're creating an object, you're calling it.
okay, I thought like we are actually initializing the instance variables. That's why I had a question.
No, no. To initialize that variables, instance variables, we use constructor always. You call a constructor. Always you're going to call a constructor. Yes.
Yeah. Okay, got it. Thank you.
Okay. Fine. So now we have static variables. You see, the memory for the instance variables, as I told you people, it will be allocated as part of that object itself, right? Instance variables, they will be part of the object. So what about the static variables? You know, static variables, you will find that the memory for the static variables is allocated separately. It won't be part of the object here. The memory for the static variables is allocated separately. It won't be part of the object. A separate memory area is used for that purpose. Separate memory area is used for that purpose. Yes. Okay. You know, in order to access that instance variables, we use a reference, object reference, because that instance variables, they're part of that object. So you need to use a reference, object reference. Yes. See, after creating the object itself, yes. So after the memory is allocated for that object, after the memory for this variables is allocated for this object, and sorry, after the memory is allocated for the object and the instance variables, the constructor will be called, because constructor's responsibility is to assign some initial values or assign some values to that instance variables. So after the memory is allocated, then only the constructor will be able to do that, can assign some values to that instance variables. Only when the memory is allocated, it can do it, right? So it will be called after the object is created. Yeah. So you can just refer to the class where I was talking about object creation statement, especially. I guess in the last class itself we were talking about it. Just review that object creation statement notes once, you'll understand. Okay, it is divided into three parts as I told you people. Okay, yep. So now, okay, you need a reference, object reference to access the instance variables. So how about the static variables? How about static variables? Static variables, as I told you people, they're not part of the object. Static variables, they're not part of the object. So the memory is separately allocated. In order to access the static variables, in order to access static variables, you need to use class name. We say static variables, they belong to the class. We say static variables, they belong to the class. You see, so to access that static variable, I'll use the class name here. Okay, so savings account dot interest rate. That's it. Yeah. So class name is used for that purpose. We use the class name. Okay. So let me run this code. You see, you got the value which is stored in that static variable. Yes. This is about static variables. Let's move on. So far, you see, we have represented the properties of an object. Now, we'll talk about the behaviors. Properties, we call it as a state also. So far, we were talking about properties of an object. Now, we'll talk about behaviors of an object. So, what are the behaviors of an object? Can you people tell me? What will be the behaviors of an object? Behaviors of the savings account object. Yes, you see, you'll have withdraw, deposit, transfer, and so on. So these are the various behaviors, or we say actions. These are the actions, behaviors. Now, how do we represent the behaviors of an object in Java? In the class, how do we represent the behaviors of an object? You know that the properties of an object, we represent them as variables, right? Yes. Behaviors of an object, they are represented as methods. That's right. Basically, behaviors of an object, they are represented as methods. Yes. Yes. So let's try to represent the behaviors of this object. Okay. So in the savings account class, now you see, I'll represent the behaviors. So behaviors means the other name for it, I can say that they are nothing but actions performed on the object. Okay. Yes. By an object or on an object, I can say. Actions performed by an object or on an object. So you see, we perform that withdraw action. So that withdraw action or withdraw behavior, I'll represent it as a method. So you see, this is the method. Now the customers, in order to withdraw the amount from their account when they perform this withdraw action, they'll specify the withdrawal amount, right? They'll specify the withdrawal amount. So that will be the input for this method. Withdrawal amount will be the input for this method. Yes. So here the bank has got certain rules for withdrawal. The banks have got certain rules for withdrawal. Withdrawal from the savings account, you see, what is a bank rule? You'll find that the withdrawal amount should be less than or equal to the balance amount. Okay, withdrawal amount should be less than or equal to the balance amount. That is one of the business rules of the bank, right? Yes. You see, I'll write the condition for that. We'll implement that business rule, I can say. So this dot withdraw, sorry, this dot balance should be, sorry, the withdrawal amount should be less than or equal to the balance. Yes. So this rule has to be satisfied. Then only we'll allow the user to withdraw. We'll update that balance. We'll deduct that withdrawal amounts from the balance. Else, otherwise, we'll print a message. So, see, I'll print a message. You have insufficient balance. You have insufficient funds. Let's say. You have insufficient funds. You know what? This code which we have written here, I'm sorry, this code, it implements the business rules, right? It implements the business rule. This kind of code is actually called as business logic. It is actually known as business logic. The code which we write to implement the business rules, such code is actually called as business logic here. Okay, such code is actually called as business logic. So you know what, here generally in the real world, when we talk about a real world object, so when we perform any action on that object, so there is a possibility that the state of that object can change or may change. The state of the object will change. In this case, you see, if we perform this withdraw action on the savings account object, you see the state of that account object will change. So the balance will be updated here, I can say. Balance will be updated. Yes. Now, yes, but I always recommend you people to use this, and I'll tell you people the reason why we use this word. So now you see we have two different objects, two savings account objects, right? We have created two savings account objects. I want to perform the withdraw action on the first savings account object. I want to perform the withdraw action on the first savings account object. So what to do? So if you want to perform withdraw action on the first savings account object, then use the first savings account object reference account dot withdraw of, let's say, 2000. That's it. Use that first savings account object reference. Now that withdraw method, you see when it is invoked, the withdraw method, when it is invoked, you see we are using that first account object reference, right? Using first account object reference to call that withdraw method. So that object reference which we have used to call the method, you will find that it is passed implicitly to the method and it is stored in this variable. Same as constructors. Okay, we have discussed about this in constructors, right? So that newly created object reference is passed on to the constructor and it is stored in this. Similarly, here also, when a method is invoked, okay, when a method is invoked, you see, in order to invoke that method or call that method, you will find that that object reference is used, right? In order to call that withdraw method. Especially I'm talking about non-static methods or instance methods. Yeah, this method. You see, we're using that object reference to call that method. So that object reference which is used to call that method, it is implicitly passed on to the method and it is stored in this variable. Okay, that means now this is referring to which object here? That means this is referring to which object? Yes, it refers to the first account object. It refers to the first account object, first savings account object. For suppose here, if I do this, account 2 dot withdraw. If I do this, account 2 dot withdraw, then what happens? This, it refers to which object? This in that account, sorry, in that withdraw method. This in the withdraw method, it refers to which object? Yes, second account object, account 2. Okay, so this way you see always to call that method we use a reference, and that reference which is used to call that method, it is passed on to the method implicitly and it is stored in this variable. We say current object reference. You can make a note of it. Okay, so you see when it comes to non-static methods, this is a non-static method. You know what we did, the methods generally which we define in the class, you see it's a non-static method or we say instance method. So what is the specialty of this method? This method basically it operates on an object or an instance, I can say. This method basically it operates on an object or an instance. You see, I'll be using the term instance a lot. Instance means, what is it? What do you people think? Instance means, instance means it's not a point here, especially in the programming when it comes to Java. Instance means we are referring to an object. Instance or object means the same. So basically you can think of it as a synonym here. Instance means an object itself. Okay, so you'll find that I'll be using the terms instance or object. Here both means the same, I'm referring to the same thing. Okay, sure. Sure, Aarti, you can. So the specialty about instance method. So what an instance method does? Okay, you're welcome. So instance method, instance or non-static method instance method, sorry, operates on an object. Instance method operates on an object, I can say. So in order, sorry, we use an object reference to call an instance method. We use an object reference to call an instance method. So the reference is passed implicitly to the method and it is stored in this variable. It is stored in this variable. That's it. So we use an object reference to call an instance method. The reference is passed implicitly to the method and it is stored in this variable. It is stored in this variable. Okay. So this way again, that reference is passed on to that object. Why the sorry to the method? Why the reference is needed for this method here? Why it is passed on to the method? What do you people think? Why that object reference is passed on to the method? Why the object reference is passed on implicitly to the method? Yes, because you see, this is how this is how the method will understand. This is how the method will understand on which object it is supposed to operate. This is how the method will understand on which object the method is supposed to operate. The method is supposed to operate on an object, right? So on which object the method is supposed to operate? So that object reference is implicitly passed on to the method. So this here, this dot balance means you're referring to the copy of that balance variable which is in that first in the object whose reference is used. So here you see which object reference is used, second account object reference. So this dot balance means you're referring to the copy of that balance variable which is in the second account object. Every object has got its own copy of instance variables, right? Now on which copy of instance variables you will be operating, or that method is supposed to operate. You see, that reference helps the method to understand on which copy of instance variables or on which object it is supposed to operate. Yeah. So let me do this here. I'll call that withdraw method on the first account object and will display the balance. Okay, we are calling this withdraw method on the first account object and will display the balance here. Okay, you see the balance is 5,000. So initial balance of that account object is 5,000. Now it prints 3,000. Okay. So is it clear for everyone? Okay. Now you see, you'll find that actually even if you don't use this, still it works. Even if you don't use this, still it works. But if you don't add this here, in that case, you know what happens? Anyone has got any idea about it? You know, if you don't use this, the compiler, during the compile time, it will definitely add this. It will definitely add this dot balance. It will do it. So instead, if we don't add it, the compiler is going to do that definitely. It will add this. Okay. So now, when you see, sometimes you may consider this case, saying account class. You see, you have balance parameter, the parameter with the name balance, the parameter with the name balance. You see, the parameter name and the instance variable name are same. The parameter name and instance variable name are same. You know, in this case, if you want to refer to that instance variable, then it is mandatory to use this. You have to use this in this case. Otherwise, if you say only balance, you see this balance here, only balance, it refers to which variable? It refers to the local variable. Only balance here refers to the local variable. If you want to refer to the instance variable, then what you will do? Use this. Sometimes you may have two variables, instance variables and the parameters. They may have same name. In that case, to refer to instance variables, you have to definitely use this mandatorily. You have to use this mandatorily in that case. Otherwise, you see, even if you don't use this, you see, in withdraw method, so we have only one copy of that variable. There is only one balance variable. You don't have any local variable or parameter here. Okay, so you don't need, even if you don't use this, it works here. Even if you don't use this, it works. But the compiler will add this if you don't add it. Definitely, it is going to do that. Yes. So see, similarly, we can also implement the withdraw method here. Sorry, deposit method. Similarly, we can also implement deposit method. See, int deposit amount. If deposit amount is greater than or equal to 0, it should be greater than or equal to 0, right? People can't deposit 0 or negative value, negative amounts. Yeah. This dot balance equal to this dot balance plus deposit amount. Else will print a message. What is it? Invalid deposit amount. Invalid deposit amount. Okay. So far what we did. So is it clear for you people? So anyone got any questions, please let me know. Okay, good. Next, I'll talk about static methods. Static methods. We saw instance methods. You see, instance method operates on an object. You see, in the brackets, you can also make a note of it. And instance variables, I can say. In the object, you'll have instance variables, right? In the object, you'll have instance variables. So it operates on the instance variables also. So how about static methods? Is anyone familiar with static methods? Yes, they operate on. Why we use static methods? Purpose of static methods. Okay. Static methods they can be used by they can be accessed by the class name. And what else? So why do we use static methods? Yeah, okay. Static variables they don't act on instance variables, that's right. You know, I can say that we can use static variables to operate sorry, we can use static methods to operate on the static variables, I can say. We can use static methods to operate on the static variables. The way, yes, the way we use instance method to operate on an instance or an object and its instance variables. Similarly, we can use a static method to operate on static variables. Static methods can be used to operate on static variables, I can say. Yes. So you see, defining a static method is not a big deal. So all you need to do is just use the keyword static. That's it. So if a method is declared as static, that means it's a static method. For example, here you see, I can do this get interest rate. Okay, this is a static method, I can say. So this method is declared as static. You will find that using that keyword static. That is how a static method is defined. We use static keyword. So what exactly this method is doing here? Can you people tell me? When this method is invoked, so what it does? It returns the interest rate. Okay. It returns the value which is stored in the interest rate variable, right? It returns the value which is stored in the interest rate variable. Yes. You know, in order to call that static method, so we use the class name. You see, I can do this. I'm using the class name savings account dot class name. So instance methods we use object reference to call them. For instance methods we use object reference to call them. If it is a static method, we use the class name dot method name. That's it. You know, unlike instance methods, unlike instance methods, static methods will not have access to that object reference or something like that. Static variables will not have access to any object reference. You see, I can't do this. This dot balance, you can't use this here in static methods. So because you see, to call a static method, object reference is not used. So hence any reference, any type of reference is not passed on to the static method. Okay? Yes. No reference is passed on to the static method. Static methods will be invoked using the class name. So in the static methods you can access only static variables. So you cannot use this in static context. It says you cannot use this here. So it's not valid. So I can say that we use static methods to operate on the static variables. We use instance methods to operate on the instance variables or on an object, I can say. In an object, what you have instance variables itself, right? Yes. So static methods for static variables, instance methods for instance variables. But you know what? One more thing. Now you understood that in a static method, you cannot access instance variables. Can we access static variables in a instance method? The other way, vice versa, is it possible? can we access static variables in the instance method? Yes, you can do that. Okay, you see, you can access them. There won't be any problem. You see, interest rate. Sorry, you can do this interest rate. It still works. There won't be any problem. So in an instance method, you can access both static and non-static methods. Okay. Yes. That means here I expect one doubt from you people in this case. From this observation, few people may have a doubt. Yes. Anyone got any question or any doubt in this regard? Um, because we don't have a reference to access them, implicitly reference is not passed on. Unlike your instance methods, for static methods, the reference object reference is not passed on. Okay, so this variable is not available which holds the reference to that object. I was expecting another question. If we can access both static and non-static methods, sorry, static and non-static variables in an instance method, if we can access both static and non-static methods, so sorry, static and non-static variables in an instance method, then what is the purpose of a static method? See, we can access both static and non-static variables in an instance method, right? Then why do we need a static method? Can't we use instance method itself for working with both static and non-static variables? Can't we use instance method itself for both static and non-static variables? Why do we need the static method again? Hope everyone got the question. You people saw that we can access both static and non-static variables in an instance method, right? So then can't we use only instance methods? Why do we need a static method again? Hope you people got my question. I'm talking about instance method. So the need for static method. So when we can access both static and non-static variables in an instance method, why do we need static method? Yeah, yes. So the answer for this question is you will find that in order to call an instance method, always you need an object reference, right? Whereas for a static method, you don't need any object reference. So accessing the static variables through the static methods would be easy because to call that method you don't need any reference. We can directly use the class name. Unnecessarily we don't need to create an object to call an instance method here. Yes, we are only working with static variables. So is it clear, all of you? Okay, so this is about static and non-static methods. So now we'll talk about, okay, the method signature. But before we move on, so let me tell you people this. You see, members of a class, when we talk about members of a class, we can broadly classify the members of a class into static members and non-static members. Static and non-static. When I say static members, what does that mean? When I say static members, what does that mean? Yeah. See, static members means, yes, static variables and static methods. That's right. Static variables and static methods. Okay, so what about non-static members? Yes, non-static members means you can say instance variables and instance methods. Instance variables and instance methods. Okay, so this way the members of a class can be broadly classified into two types. And you see here I can say that they represent this properties. Is it the variables which we saw, both static and non-static variables? They represent the properties of an object, right? And methods, they represent the behaviors of an object. Methods, they represent behaviors of an object. Yeah. Next, we'll talk about method signature. Method signature. We'll try to explore all the object-oriented features one by one. As of now, you see, first today we understood completely what is how to represent a real-world object, its properties and behaviors. Okay. Yes. So now we'll talk about method signature. So what is a method signature? Yes. Yes, method signature means it includes method name and parameters types list. Only parameter types list. Method name, method signature means it's method name and parameter types list here. So that means, for example, here, if you consider withdraw method, so what is the method signature of this withdraw method? Withdraw. Here, it will be withdraw of int. That's it. That's it. You know what? Here, the parameter name is not considered. The parameter name is not considered. Only parameter type is considered. Okay. Yeah. Only parameter type is considered. This is the this is the method signature. So the method signature of this method deposit is deposit of int. That's it. Deposit of int. So you need to understand method signature. This is the first point. Second point is Java distinguishes the methods based on method signature. It will distinguish the methods based on Java will distinguish, I can say it's better. Java will distinguish the methods based on method signature. Yes. So for suppose, let's say you have this withdraw method. Okay. Now let's say we have another withdraw method. Parameter name is, let's say, amount, and the return type is int or float. Now, are these two methods same or different? Are these two methods same or different? You know, for us, it might be different. You know, for Java, these two methods are same. For Java, these two methods are same. withdraw of int, withdraw of int. That's it. Okay, because Java will distinguish the methods based on the method signature. If the method signature is same, then the methods are same. The method signature is same, then the methods are same for Java. It won't take the return type, parameter name, and all those things. Yeah. Okay. So you cannot define two methods in the class with the same signature. You see, if I try to add this withdraw method which returns a float value, let's say, okay, something like this, don't worry about the method logic. You see, if I add a method here, what happens? Let's see, it throws an error. Duplicate withdraw method. Duplicate method withdraw of int in type savings account. Yes, but Java won't consider the return type. As I told you people, Java will differentiate the methods based on the method signature. Okay, so return type is not a concern for Java. So, but you should not define two methods with the same signature. If so, it is an error. This is about method signature. So, why you know Java will not allow us to do this? Define two methods with the same signature. Because you see, for example, let's say you have these two methods which take integer value. For suppose if you call this withdraw method by passing an integer value, so in this case, you see for this method call, now we have two methods which are qualified. For this method call, I can say that we have two methods which are qualified. Am I right? You got the point, all of you? You see, you'll find that we have two withdraw methods which take an integer value. That means now which method has to be called for that method call? Which method should be invoked? Right? You see, withdraw of you're passing an integer value. So we have two withdraw methods which take the integer value. Both the withdraw method's name is sorry, both the method names is same withdraw. Both the methods take an integer value. That will be a confusion or an ambiguity. So to avoid this, we can't define two methods with the same signature in Java. Java won't ever allow us to do this. Okay, fine. So is it clear for everyone? Anyone got any questions or doubts in this regard? Okay, good. So hope this is clear for everyone. Okay. Yeah. If so, today, please excuse me. I'll stop it 1 hour early. Okay. Yeah. So we'll do one thing. We'll meet tomorrow at our regular time. So tomorrow, we got a class at 7 p.m. Central Indian time, same time as we did today. Every day the class will be at 7 p.m. Indian time. So tomorrow we got a class at 7 p.m. Indian time. In the next class, I'll talk about polymorphism, how to implement polymorphism, and also we'll start with inheritance. Inheritance. So these are the two topics which we'll be discussing in the next session. So please go through polymorphism and inheritance before coming to the next session. So tomorrow we'll have a full-fledged session. Okay? Please excuse me today. Yeah. Okay then. So that's it. Thank you. Bye bye, all of you.